Hey everyone, today we're looking at section 3.5 homework. The first couple problems are just taking the derivative using our new trig rules. So if I'm looking at this number 1 plus x minus cosine of x, the derivative of 1 is 0, the derivative of x is 1, and the derivative of cosine is negative sign, so it'd be minus the negative sign is plus sign. So the derivative is 1 plus sine of x. For number 3, x to negative 1 plus 5 sine of x. Again, bring the negative 1 down, subtract 1, minus x to the minus 2. And I can leave that 5 stuck to the sign. 5 times sine of x is 5 cos of x. And if you want, you can leave it just like that, or flip this down, negative 1 over x squared plus 5 cos x. For number 5, the derivative of 4 is 0, and then I need to do a product rule here because it's going to be x squared times sine of x. If you want, I'm going to add this plus negative 1 just to keep track of the negative sign. I'm going to say this is negative 1x squared is the first function, and then sine of x is the second function. So I'm going to set up my product rule here. So negative 1x squared derivative times sine of x plus negative 1x squared times the derivative of sine of x. So the derivative of negative 1x squared is going to be negative 2x to the 1 times sine of x. And then all of this stuck to a cosine is going to be minus x squared cosine of x. Again, setting up that product rule. So for 7, there's 2 different ways you can do it. You can either it's 4 over cosine of x. So you can either bring the cosine up to make this 4 secant of x, take the derivative of 4 secant of x, that's equal to 4 secant of x times tangent of x. Or you can set up your quotient rule. So it'd be the derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared. This derivative is going to be 0, so this is all gone right here. And then this derivative is going to be negative sign, so negative 4 times the negative sine of x is going to be positive 4 sine of x over that cosine squared. And then if you're like, well, how is that the same? Well, what you can do is you can write this as a 4, and then you can write this as 1 over cosine of x times sine of x over cosine of x. And if you notice again, 4 times 1 times sine is going to be 4 sine of x, and then cosine times cosine is cosine squared. And writing in this form, you can see this is going to be 4 times secant of x times tangent of x. And you'll get the same thing. So any of these forms are fine for your final derivative. So 9, you have to set up a quotient rule. So again, you can't split the denominators up, but you can split up a numerator. So in this case, there's nothing to split up. So I do have to set up a quotient rule on this one here. So I'm going to take the derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared. So the derivative of cotangent of x is negative cosecant squared of x. Bring this down, leave it stuck there, minus, leave this here. And then the derivative of 1 plus cotangent of x is going to be 0 plus, and then the derivative of cotangent is negative cosecant squared of x. So again, I'm going to leave that all like that, all over the denominator squared. And again, really just make your flashcards and get these derivatives down as quick as you can. The derivative of sine is cosine. The derivative of cosine is negative sine. The derivative of secant is secant tangent. The derivative of cosecant is negative cosecant cotangent. The derivative of tangent is secant squared. The derivative of cotangent is negative cosecant squared. So getting those down as quick as you can just to make your life easier. Okay, so 11 just wants us to create so the position, velocity, and acceleration equations, and then to describe the motion. So I start with this position as 5 sine t. So the derivative of position is velocity. So that would be 5 cosine of t. And then the derivative of velocity is acceleration. So the derivative of cosine is negative sine. So it'd be negative 5 sine of t. So there's my position, velocity, and acceleration. Now we have to use our knowledge of the sine and cosine function. So at time 0, sine of 0 is equal to 0, because that's the y length of the reference triangle. So I start at a position of 0, and then I go, sine of pi over 2 is going to be 1. So then it's 5 times 1. So I go to the 5 position, and then sine of pi is 0. So I'm back to the 0 position, and then sine of 3 pi over 2 is going to be negative 1, which is going to make this negative 5, and then sine of 2 pi is equal to 0. So looking at the position of this function, it's going to start at a position of 0, go to 5, 0, negative 5, 0. Again, this is going to be one of those oscillating motions that's going to oscillate between 5 and negative 5 with a center line or a midline of 0. For 13, it wants us to create the velocity, speed, and acceleration, and then find the velocity, speed, and acceleration at time pi over 4, exactly at time pi over 4. So here's my position, and then if I create the velocity is going to be, the derivative is 0 plus 3 cosine of t. So here's my velocity equation. And if you want the speed, well, that's just the absolute value, so you can just slap an absolute value on the outside if you wanted to graph that or take a look at that. But really, just make sure everything's positive. Then for acceleration, let's go back to velocity, take the derivative of that. The derivative of cosine is negative sine, so it'd be negative 3 sine of t. And then at pi over 4, well, if you need a little reminder, that's 45 degrees. So if I draw my little 45 degrees here, 45 degrees, that's 1 and root 2. So if I want the velocity at time pi over 4, it'd be 3 times cosine of pi over 4 is 1 over root 2. So it's going to be 3 over root 2 if you just multiplied the numerators and denominators together. Since that's already positive, the velocity and speed are going to be exactly the same thing because they're both positive. For the acceleration, it's going to be negative 3 times the sine is going to be also 1 over root 2. Sorry, sine is opposite over hypotenuse, 1 over root 2. So it'd be negative 3 times 1 over root 2. So it's like, okay, well, what's happening with this particle? So this function here, if you look at 2 plus 3 sine of t, at time 0, sine of 0 is still 0, so you're at the 2 position. So again, this is your midline. You're going to start at 2. And then when sine gets to pi over 2, this whole thing is going to equal 1. So sine of 90 degrees or pi over 2 is 1. So you're going to add the 3 to the 2 to go up to 5. At pi, this is back to 0, so you're back to the 2 position value. And then when sine of 3 pi over 2 is equal to negative 1, then you're going to subtract a 3, bring you to position of 2 minus 3, which is minus 1. And then sine of 2 pi is 0 again, so you're back to the position of 2. So again, really the only thing a sine function can do is equal 0, 1, 0, negative 1, 0, 1. So if you look at what is this position going to do, we're going to start at a position of 2, and then go up to 5, and then go back to 2, and then negative 1, and then back to 2. And it's going to oscillate and keep doing that forever and ever in both directions. So that's 13. For 17, it just wanted you to create the jerk equation. So let's just go straight down through the line here. So position was given at 2 cosine of t. So the derivative of this, the derivative of cosine is negative sine. So the velocity is going to be negative 2 sine of t. The acceleration is going to be the derivative of that. So the derivative of sine is cosine. So it'd be negative 2 cosine of t. And then the derivative of this is going to be that new idea of this new jerk equation, which is the change in acceleration. And so the derivative of negative 2 cosine of t, the derivative of cosine is negative sine. So that would cancel out with that negative, making a positive 2 sine of t. For 22, is asking to find when the tangent line and the normal line at pi over 2. So again, at pi over 4. So at pi over 4, for the secant function, secant is the flip of the cosine. So if the cosine of 45 degrees is 1 over root 2, then the secant is just root 2 over 1. So I put pi over 4 into the secant function, which is the same as just flipping 1 over cosine, and I get root 2 over 1. So there's my point. For my slope, I need to take the derivative of secant of x. The derivative of secant of x is secant of x times tangent of x. And I'm going to put pi over 4 into that equation. So I already know what pi over 4 into secant of x is because I did that up here. So that's equal to root 2. And then tangent of pi over 4 or 45 degrees is opposite over adjacent. So that's equal to 1. So that's root 2 over 1. So that's my slope. Again, take the derivative equation, plug pi over 4 into the derivative to get the slope of the tangent line. So now I have my point and my slope. Y minus root 2 is equal to the slope root 2 times x minus pi over 4. Tangent line's done. For a normal line, point is the same, and just take opposite reciprocal slope and leave it just like that. Done there. Okay, for 27, This is where we wanted to see that the secant and the cosine both have horizontal tangent lines at x equals 0. So in order to see that, I'm going to take the derivative of secant, and that's secant of x times tangent of x. And sometimes it's hard for me to see, like, okay, well, what is the secant of 0 and tangent of 0 if you're forgetting that. So again, secant is 1 over cosine, and tangent is sine over cosine, like we did up here. Where did we do that? All right. Oh, this one's right here when it's like the secant is sine over cosine squared, which is the same as secant of tangent. Again, just writing this as, secant is the same as 1 over cosine of x. The tangent is sine of x over cosine of x. And if I multiply those together, multiply fractions, multiply across, I get sine of x over cosine squared of x. So here is my derivative, and I'm going to put 0 into this here. So sine of 0, well, if we stick our hand out, what is the y length of that reference triangle? The sine of 0 is 0. And then what's the cosine of 0? So cosine of 0, again, don't forget, when it says cosine squared, really what that means is this. Like that, if you remember, like, what is that? So I'm going to put 0 into cosine. What is the x length of the reference triangle at 0? That is equal to 1. 1 squared is 1. So then I have 0 over 1, which is 0. Whenever you have a fraction and the numerator equals 0, the output equals 0. Okay, so the derivative of cosine is negative sine. So if I put 0 into this function here, negative sine of 0 is equal to 0. So both of these functions, the secant and the cosine, have horizontal tangents. Again, horizontal tangent lines means slope of tangent line equals 0 at x equals 0. So for 35, it wants me to take the second derivative of the cosecant of x graph. So the first thing I'm going to do is just take the derivative. The derivative of cosecant is negative cosecant of x times cotangent of x. So there's my first derivative. And if you want to do the second derivative, well, now I need to do a product rule. So I'm going to set that up first. Here's my second derivative is equal to, and I'm going to leave that negative just with this function here. The derivative of the first times the second plus the first times the derivative of the second. And then the derivative of negative cosecant of x, well, the derivative of cosecant of x is negative cosecant of x times cotangent of x. So with that negative in there, it's going to make it positive. So the derivative of this is going to be cosecant of x times cotangent of x. And I'm going to multiply that by this cotangent of x. And then I'm going to leave this cosecant of x, really the negative one here. And then the derivative of cotangent of x is negative cosecant squared. So that negative and the negative coming out of that will cancel out, just making a plus here. And so if you want, you can leave it just like that, or a little simplifying. I have a cosecant of x, and then I have two of these. So cosecant of x times cotangent squared of x plus cosecant of x, that should be cubed. Let me fix that right here. Cosecant of x cubed. Great. Okay, so for 37, we want to see continuous differentiable, or solve for the value that's going to make it continuous. Here it is here. So, and then does that same value of b, will it also make it differentiable? Well, let's check that out. So again, what this is really saying is adjust the y-intercept to make these two functions connect up. Well, I already know that the cosine of 0, so if I put 0, checking the limit from the right, plug 0 into cosine of 0 and I get 1. And if I plug 0 into this piece here, that would be checking the limit from the left, so that would be 0 plus b. And in order to be continuous, I need that limit from the left to equal the limit from the right. And I need, in order for the limit to exist and equal that value, and then I need limit value to equal function value in order to make it continuous. But really when I do that, cosine of 0 is 1, so b equals 1. So I need this to be the x plus 1 line. But if I draw an x plus 1, and if I draw that in, x plus 1 looks like this. And then cosine is going to do that. So it's looking like I'm going to get this kind of sharp corner. It's going to be around it, because this is coming in with a slope from the left is the slope of the line. And then I can just plug in 0 into the derivative of cosine, really plug 0 into the derivative of both of these to check, is this function differentiable at x equals 0? Well, the slope of this line is 1, so that's the derivative from the left. And then if I take the derivative of cosine, that's negative sine of x. If I plug 0 into that, I get 0. So I do have a corner there. So if I kind of like focus in, it's going to look like that, and then it's going to look like that. Oops, let me clean that up a little bit. So it's going to be 1, and then this nice rounding off, something like that. So there's going to be a corner, because the derivative from the left is 1, and the derivative from the right is 0. So not differentiable. Yes, continuous, not differentiable. So 39 is looking for the 725th derivative of sine of x. Let's just check that out. 725th derivative of sine of x. Well, let's see what we can do. Let's see if we can see a pattern here. So the derivative of sine is cosine. The derivative of cosine is negative sine. The derivative of negative sine is negative cosine. And as soon as I take the fourth derivative, the derivative of cosine is negative sine. So with that negative, I'm back to where I started. So what I'm seeing here is every fourth derivative is going to take me back to where I started. So if you multiply that out, by what number is divisible by 4, that's going to be 724. So that 724th derivative is going to be sine of x. So then the 725th would just be the derivative of that, which is going to be cosine. So that's it. Hopefully you had fun with these. Again, we're bringing in these old applications and we're just adding new functions to take the derivative. Now we can take the derivative of our 6 trig functions. So hopefully you had fun, and we'll see you next time. Take care, everybody.